Hi, my dear students. Welcome to ME Educational Institutions. Today, we are going to solve some problems based on mechanical properties of solids. Here, we need to discuss stress and strain calculations in the wire when the body of mass m is attached to it and the body is in vertical circular motion. Here, we need to calculate stress strain calculations in the wire. Okay, so let's start the session. Now we can have a look on the vertical circular motion of the body. Here we need to do stress strain calculations in the wire when the body of mass m is attached to the wire and the body is in vertical circular motion of the body and at maximum angular velocity condition. We are discussing vertical circular motion of the body for maximum angular velocity condition. See here, this is the support, hinge support, and this is the wire. I can say this would be the wire is in vertical circular motion, and here this is the vertical circular motion of the body. Vertical circular motion of the body. Circular motion of the body. And the body is at top of the circular path. Motion of the body. And the body is at top of the circular path. This is the body at the top of the circular path. Here the body is at top of the circular path. Now angle is 90 degrees. Theta equal to 90 degrees. Here we are discussing maximum angular velocity condition. Now angular velocity omega. Here I can say that maximum angular velocity omega equal to omega maximum. Just observe maximum angular velocity condition. Draw the free body diagram. Weight of the body always act vertically downward direction. Tension in the string always pull the body. This is the tension in the string. Always pull the body. Centrifugal forces always act away from the center of circular motion. This is the center of circular motion. Away from the center of circular motion. Here our condition is what? Maximum angular velocity condition. Maximum. Omega maximum. Then FC maximum. Maximum centrifugal forces. Here when the body is at top of the circular path, omega maximum is the maximum angular velocity of the body. I can say that maximum angular velocity of the body. Angular velocity of the body. Velocity of the body. Here the parameters are omega maximum equal to maximum angular velocity of the body. Here R equals to L. That means radius of rotation of the circular path becomes equal to the length of the wire. Okay, radius of rotation of circular path. This would be radius of circular path. Radius of circular path. Here the condition is maximum angular velocity condition. This would be length of the wire. I can say that length of the wire. Capital A is the area of cross section of the wire. Area of cross section of the wire. Area of cross section of the wire. And maximum angular velocity condition. Here we are discussing at maximum angular velocity condition, theta equal to 90 degrees. Maximum angular velocity condition theta measured in counterclockwise direction with respect to the positive direction of x-axis is positive, theta equal to 90 degrees, and r is equal to L you will be getting at maximum angular velocity condition. Radius of circular path becomes equal to the length of the wire, theta equal to 90 degrees when the body is at top of the circular path. We represented all the forces which are acting on the body. Now we can have a look on the free body diagram for the body. Centrifugal force is acting, tension and weight of the body always act vertically downward direction. We are working on maximum angular velocity condition. Here it is what? Omega maximum. Angular velocity is maximum and Fc also maximum. Understood na? So D'Alembert's principle, here we are representing centrifugal forces in the free body diagram. Means dynamic problem converted into static problem. Centrifugal forces always act opposite to the direction of radial acceleration, that is centripetal acceleration. So dynamic problem converted into static problem, we can apply static equilibrium equations. Sigma V equals to 0. Sigma V equals to 0 means sum of the upward force equal to sum of the downward forces. What are the upward forces here? Tell me. Sum of the downward force equal to sum of the upward forces. T plus mg. T plus mg equal to Fc maximum. Maximum centrifugal force. Maximum centrifugal force. Here working on maximum angular velocity condition. Tension in the string plus weight of the body equal to maximum centrifugal force. Mr omega maximum square. Omega maximum square. So what is the tension in the string? What is the tension in the string? Equal to Mr omega maximum square minus mg will be getting. This is the tension in the string. T refers to the expression for tension in the string. Tension in the string. Tension in the string. Clear? So now tell me, what is the omega maximum when the rod and the body is at top of the circular path? Here Mr omega maximum square. Here omega maximum is how much? Omega maximum square equal to T plus mg. T plus mg by Mr you will be getting omega maximum equal to square root of T plus mg by Mr. T plus mg by Mr. This is entire discussion is for when the body is at top of the circular path. Top of the circular path. Okay, so this is the maximum angular velocity, and here I can say maximum tension in the string when the body is at top of the circular path. Now we need to calculate stress strain calculations. Now we need to do stress strain calculations. This is the wire tension in the string. Tension in the string means it is a tensile force. Tensile stresses induced in the wire. Maximum angular velocity condition. Here we need to work on the stress strain calculations in the wire. So what are the stress strain calculations? Tell me. Stress induced in the wire. I want to tell you what is the magnitude of stress. Magnitude of stress, that would be, this would be how much? A, B is at top, AB, sigma AB, stress induced in the wire, stress induced in the wire, stress induced in the wire is nothing but sigma AB. Stress induced in the wire AB when the body is at top of the circular path. Sigma AB equal to load acting on the wire AB by area of cross section. Area of cross section of the wire. Okay, so here I can write sigma AB. What is the load acting on the wire? Tension in the string. This would be tension in the string by area of cross section. What is the tension in the string? Mass of the wire, radius of rotation of circular path, maximum angular velocity of the wire, square minus mg by area of cross section of the wire. This is the magnitude of stresses induced in the wire. Now coming to strain produced in the wire. Here I can say that strain produced in the wire. Strain produced in the wire. Strain produced in the wire is nothing but epsilon AB. Strain produced in the wire. We need to apply Hooke's law. Sigma AB, stress, longitudinal stress directly proportional to longitudinal strain. Hooke's law is valid up to proportionality limit. Longitudinal stress equals to Young's modulus E epsilon AB. What is the longitudinal stress induced in the wire? Here it is how much? Mass, radius of rotation of the circular path, mr omega maximum square minus mg by area of cross section. Here you will be getting equal to E epsilon AB. Finally, strain produced in the wire, epsilon AB equal to mr omega maximum angular velocity condition minus mg by AE you will be getting. This is the strain produced in the wire. Now I am interested to calculate axial deformation in the wire. I am interested to calculate axial deformation in the wire. This would be axial deformation in the wire delta LAB. I want to calculate axial deformation in the wire. Axial deformation. Axial deformation in the wire. Delta LAB. This is the axial deformation in the wire. Epsilon AB. Here I want to say strain produced in the wire is nothing but change in dimensions by original dimensions. Length of the wire L. Okay. So here I want to say strain produced in the wire equal to axial deformation in the wire by length of the wire AB, original length of the wire, that is equal to delta L AB by L you will be getting. So finally, what is the delta L AB? Tell me. Delta L axial deformation in the wire equals to L times epsilon AB. L times epsilon AB. Finally, delta L axial deformation in the wire equals to MR omega maximum square minus mg by AE. AE refers to axial rigidity of the wire into length of the wire. In this manner, we can calculate axial deformation in the wire when the body is connected, when the body of mass M is attached to the wire and wire is in vertical circular motion of the body and at the maximum angular velocity condition and the body is at top of the circular path. Entire calculations valid when the body is at when the body is at top of the circular path is at top of the circular path when the body is at top of the circular path. Understood na? So stress calculations and T will be tension in the string. Here T you are getting. What is the tension T you are getting? What is the value of tension T? Equals to maximum tension in the string is at maximum angular velocity condition minus mg you will be getting. Okay, now this is the tension in the string when the body is at top of the circular path. Now we need to have a look on the tension in the string when the body is at bottom of the circular path and the body is in vertical circular motion. Understood na? So here this is vertical circular motion. Vertical circular motion of the body. Vertical circular motion of the body. Circular motion. And this is the hinge support. I can say that hinge support. This is the support. Okay. So now I want to tell you this is the theta. Theta is measured with reference to positive direction of x-axis. Theta 270 degrees. Omega maximum I can say. Omega maximum. Now weight of the body always act vertically downward direction. Tension in the string always pull the body. Centrifugal forces always act away from the center of rotation of the circular path. Center of circular path. Circular path. Understood na? Center of the circular path. Here this is maximum angular velocity condition. FC maximum you will be getting when the body is at bottom of the circular path. We are discussing the body is at bottom of the circular path. Here the body is at bottom of the circular path. Bottom of the circular path. Understood na? So entire discussion now onwards everything based on body is at bottom of the circular path and the maximum angular velocity condition, maximum angular velocity condition, T would be tension in the string. T is nothing but tension in the string. Tension in the string. Tension in the string. Here omega maximum, maximum angular velocity of the body, maximum angular velocity of the body, maximum angular velocity of the body. Understood na? So FC maximum equal to m r omega maximum square. Here actually I want to tell you one thing here. Fr is nothing but centrifugal force, maximum centrifugal force, centrifugal force. Generally Fc maximum is nothing but, here I can write it as m into radial acceleration equal to omega maximum square into r, omega square r. This would be m times r omega maximum square. Here radial acceleration will be maximum. Okay na? So under theta equal to 90 degrees, r becomes equal to L. R becomes equal to L. R is equal to L. Radius of rotation of the circular path becomes equal to length of the wire. I want to tell you one more thing here. Linear velocity of the body. V refers to linear velocity of the body. Linear velocity of the body. What is the linear velocity of the body here? R omega maximum into R. Understood now? Omega maximum into R. What is the maximum linear velocity? This would be the maximum linear velocity of the body when it is in circular motion. So that is, from that you can write Fc maximum equal to, from that I want to write Fc maximum equal to m times V maximum square by R. You can write V maximum square by R, you can write. Understood na? So it is very simple to write. This is the way to convert centrifugal force into this form. mv square by r. Fc is equal to mr omega square, or else mv square by r, v equal to r omega. These are the basic fundamentals of circular motion. We are applying it in mechanical properties of solids. Now we can have a look on the free body diagram for the body. This body of mass m. This is the body of mass m. Tension always pull the body. Here centrifugal force, I can say this is maximum centrifugal force. It is acting downward direction, and weight always act vertically downward direction. Fc maximum. Okay, here it is what? Free body diagram for the body of mass m. We need to apply D'Alembert's principle. This is at maximum angular velocity condition, and when the body is at bottom of the circular path. Here we are discussing when the body is at bottom of the circular path, bottom of the circular path. Okay. Centrifugal forces are represented in the free body diagram. That means dynamic problem converted into static problem. We can straight away apply static equilibrium equations. Sigma V equals to 0. Sum of the upward forces equal to sum of the downward forces. Tension in the string equal to weight of the body acting downward direction and Fc maximum, maximum centrifugal forces acting downward direction. Tension in the string equal to mg plus mr omega maximum square, omega maximum square. Understood na? So here I want to tell you one more thing. I want to write this V maximum linear velocity, maximum linear velocity or omega maximum. Here I can write tension in the string mg plus mv maximum, V maximum square by r, mv square by r. Understood na? So now tell me what is V maximum square or else omega maximum square. That is up to you. What is V maximum square? V maximum square equals to T minus mg, T minus mg into R by m. You will be getting by m, we will be getting T minus mg into r by m. So what is the maximum linear velocity? Square root of T minus mg when the body is at bottom of the circular path into r by m. You will be getting. If you are interested to write omega maximum, here it is. What is the omega maximum from this expression? This is the expression from here. What is the omega maximum? Equal to square root of T minus mg, T minus mg by m times r. You will be getting m times r, maximum angular velocity of the body. V maximum, maximum linear velocity of the body. T is the tension in the string. So you will be using these expressions while solving problem. This is the case when the body is in vertical circular motion and the body is at bottom of the circular path. So if you apply, you will be getting linear velocity maximum. This would be maximum linear velocity of the body, maximum linear velocity of the body, linear velocity of the body, maximum linear velocity of the body. So tension, everything is done. Okay. So this is maximum angular velocity of the body. This would be maximum. This is the body of mass. This is the body of mass m. This would be maximum angular velocity of the body. Angular velocity of the body. Velocity of the body. Okay, maximum linear velocity of the body, maximum angular velocity of the body when the body is at bottom of the circular path. Now we need to do stress strain calculations in the wire when the body is at bottom of the circular path and the body is in vertical circular motion. This would be the wire. T is the tension in the string, tensile in nature, length of the wire, maximum angular velocity condition. L is the length of the wire. L would be length of the wire. Now we need to calculate stress produced in the wire. Here A is here, B is at bottom of the circular path. This condition, when the body here when the body is at bottom of the circular path, now we need to calculate stress induced in the wire. Stress induced in the wire is nothing but sigma AB. Here we need to calculate sigma AB. What is the maximum stress induced in the wire? Sigma AB is nothing but load acting on the wire by area of cross section of the wire. This is the stress induced in the wire, sigma AB. Load acting on the wire, PAB, by area of cross section of the wire. Area of cross section of the wire is nothing but tension T by area of cross section N. What is the tension T here? What is the tension T? Sigma AB equals to, what is the tension T here? mg plus mr omega maximum square by area of cross section. This is the stress induced in the wire. Now we need to calculate strain produced in the wire. What is the strain produced in the wire? Epsilon AB. Strain produced in the wire AB. Understood? So now what is the Hooke's law? We already know that stress induced in the wire AB is directly proportional to strain produced in the member or wire AB. Here we need to remove the proportionality and introduce the proportionality constant. Young's modulus of material of the wire equal to Young's modulus ERY epsilon AB. You can write it as finally epsilon AB equal to sigma AB by Young's modulus E equals to mg plus mr omega maximum square by AE. This would be strain produced in the wire. Strain produced in the wire. Now axial deformation in the wire. We already know that strain produced in the wire equal to change in dimensions of the wire AB by length of the wire. So axial deformation in the wire AB equals to epsilon AB into length of the wire, original length of the wire. Now tell me axial deformation delta L AB equal to epsilon AB mg, weight of the body, maximum centrifugal forces mr omega maximum square by AE into this part, length of the wire. Understood now? So we can write in terms of maximum angular velocity of the body. Okay, they may give sigma AB, everything you are in position to calculate. They may ask area of cross section of the wire for corresponding stresses, corresponding linear maximum linear velocity of the body. So everything they may, anything they can ask, you are in position to answer. Okay, so here I want to tell you centrifugal forces. You can write it as, what is the tension in the string? mg plus mr omega maximum square. You can write it as T equal to mg plus mv maximum square by r. You will be getting v maximum is the maximum linear velocity of the body. Omega maximum angular velocity of the body when the body is at bottom of the circular path, and everything related to vertical circular motion of the body. Here we discuss stress induced in the wire, axial deformation. This would be delta L AB, strain produced in the wire and everything. Here this is related to some calculations in vertical circular motion of the body when the body is attached to the wire, and we did stress strain calculations in the wire.